Yesterday, we talked about exponential growth. What's nice about today in exponential decay is that mathematically it's the same work. So it's just going to be more practice for exponential growth. So it's the same type of steps. What's different is going to be two particular things. One is going to be how you identify it's different, and the other one is how it looks different.
Can you write the steps again so like we have it on the page?
I'll copy and paste it once it's relevant, when we start doing problems, okay? So the two ways are different. Now, you could put this down. The generic exponential growth function is a times b to the x power, okay? Y equals a times b to the x power. Any growth, b is greater than 1. Now, what happens exponentially when you have something like a 2 in here? So if it was like y equals 2x, is that every step you take, you're doubling. So if it has to be bigger than 1, so the growth, so there's actual growth. If it was smaller than 1, it wouldn't grow. So technically it'd be doubling each time. If it was y 3 to the x, it would be tripling each time. If it was y 10 to the x, that would be by a factor of 10 each time. So growth is b is greater than 1. A decay is b is less than 1, but bigger than 0. So what do I mean by that? So if I were to do a decay, like y equals 1/2 x, so 1/2 to the x power, that would mean each step I'm cutting it in half, right? If I multiply something by half, it gets smaller. So every step, every time I go 1 up x, it goes half, 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 half. So a decay is something smaller than 1 because it's cutting it in half. Now, in exponential functions, you cannot put a negative in the inside of the b. It could be at the a section, but it cannot be in the b section. And the reason is because you can't have square roots of negatives. And we talked about that. We talked about square roots a while back, but you can't have square roots of negatives. So that's why it cannot be negative. It's either between 0 and 1, so something like a fraction or a decimal, or it's bigger than 1, like 2, 3, 3.5, 300, something bigger than 1 or something smaller than 1. The second thing that is different is that a growth function looks like this, and it grows to a point. So it starts off flat, and it grows and grows, kind of like the beginning part of the roller coaster. I hope you guys could kind of infer in the decay, what's going to happen is that it's getting smaller and smaller and smaller until it finally flattens out. So you notice they're kind of like X reflections. They're reflected to each other, kind of like your hands are reflections or symmetrical. They're reflected to each other. So growth, you are growing when you're going left to right. So from left to right, you're growing. That's why it's called growth. While left to right, you are decaying. So left to right, you're growing in the growth. Well, left to right, you're decaying. You're going smaller, smaller, smaller until you flatten out. Now, decay does not mean you necessarily go negative forever. It just means you flat out into a small part. So I'll pause it here. Does anyone have any questions on the differences? terms of the mathematics / steps, it's still the same. So in terms of the mathematics / steps, it's still the same. If you have any questions on the differences, please tell me. All right, you're gonna have to form that in a question so I can answer that though. So, or maybe if we do some practice with it, you'll better understand it. And I'll leave some time at the end. Maybe I'll give you some time so you can ask me questions, okay? So I'll try that. All right. So let's go to a problem. Now, if you missed yesterday's lesson, these are the steps from yesterday's lesson, literally the same written. So if you have them written already, you don't really need to write them again. But if you want to write them again for your next section, that's fine. The steps: make a table with domain -1, 0, 1, plug in the x's to find the y's. So I'm going to give you an example problem. Y equals, let's do a very basic one. 1/2 to the negative, or to the x power. 1/2 to the x power. So I should make that. There. Y equals 1/2 to the x power. The steps are exactly the same. Not only I jokingly say exactly the same, I literally copy and paste it from yesterday's lesson. All right. So, first step, let's make a table with a domain of -1, 0, 1. So I'm going to make a table. That table is going to have x and y. And in the domain, and remember the domain are your inputs or your x values. Sorry for the off-centeredness. It bothers me too. It's going to be -1, 0, 1. -1, 0, and 1. For our level / our class, we're always going to do it from -1, 0, 1. All right. And I'll try my best to color code things. So I'll do the first one in red. So 1/2 to the -1 power. Now, anything to the -1 power would get flipped to the correct position. So anything on top would go to bottom, and anything on the bottom would go to the top, which means this makes it really easy to write. I just have to flip the fraction. So to make this positive, I could flip over the fraction 2/1. Which 2/1 just becomes 2. So for my first one, it's 2. Second part, 1/2 to the 0 power. This, you have to recall the rule. Anything to the 0 power becomes 1. So anything to the 0 power becomes 1. This is just 1/2 to the 0 power. So that's 1. And the last one, 1/2 to the 1 power. 1/2 to the 1 power. Anything to the 1 power is just itself. So 1/2. That's it. 1/2. If you wanted to change that into a decimal, that would be 0.5. Yeah. And then I could ask you to graph these points, but I want to practice making the tables. Like I said, the tables are definitely more important Then the graphing, well, I believe you guys know how to graph, so I'll leave that to your own practice. It would kind of look like this though. And if I were to color code it at -1, it would be at 2, so up here. At 0, it would be at 1, so down here. And then at 1, it would be at 0.5, so halfway up. So kind of like this. Kind of like flat like that. And that matches what we said earlier. Decaying functions kind of look like a flattened top. Any questions on this one? Okay. I have the next problem up here. I want you guys to try it yourselves. This is not your exit ticket, so getting it right does not mean you get to leave early. This is just the kind of practice that I would like you to do to see how you guys are getting the lesson. You could leave the y values in a fraction. If you want to change it to decimal, that's okay also. What I would like you to privately send me is what your y values would be in this situation. So y equals 3 times 1/4 to the x power. It's really important to remember the exponent is only on the 1/4. Only on the 1/4. Nothing else and nothing more. Unintentional rhyme, though. So, Nahum, are you adding these in accident? You should be multiplying these. Or for the first one, definitely multiply.
Okay, my bad for the first one. Yeah.
And the second one's off. I'm trying to figure out why. I think you added the third one, I should say. It's also. Alyssa, the third part of yours, the first two are correct, but the third one is off. Remember, it's going to be 3 times 1/4. Don't forget that 3, which I think you forgot. Ella, you are correct. Good job. Oh, Alyssa, actually, I just looked at your whole thing. You forgot to multiply 3 for each one. So each thing there is good if it was just 1/4 to the x power. Don't forget to multiply 3. So each one needs 3. Mariah, good. 3 times 4/1 is going to give you what? And then you plug that in. Yeah, Alyssa. And I just looked at it more carefully, Alyssa. Everything you forgot to multiply by 3. I was looking at just the last one, but it was everyone you forgot to multiply by 3. So if you just took that and then multiply everything by 3, you will get it correct. Ben, good job. Yes, Mariah, the first number is that number. Alyssa, good job. Yes, Nahum, the first one is that number. And actually, let me just go out and write it for you guys. Just in case if you didn't really understand what happened, 1 to the 4th to the negative 1 power, that would become 3 times 4 over 1, which is 4 over 1 is just 4. 3 times 4 is 12. The second one would be 3 times 1 over 4 to the 0 power. So then 0 power makes it 1. So 3 times 1 equals 3. And then the third one is 3 times 1 over 4 to the 1 power. If you left it as a fraction, you could do 3 over 1 times 1 over 4, then multiply straight through 3 over 4. Or you could change 1 over 4 to a decimal, then multiply it, which some of you did, 3 times 0.25, which would be 0.75. Either answer for me is okay. Good, Haley, yeah. Except the 3.25, what you did is you added 0.25. It should be 3 times 0.25. That would fix that last one for you, okay?
Gotcha. I see that now.
Mm-hmm. All right. Now, I'm going to again copy and paste literally from the last lesson the transformation, or the plus h plus k. Copy, extend, paste. So this is the same steps, actually literally the same steps as before. You just have this third additional step, change the values by h and k. So I'll do 1, and then I'll give you 1 for your exit ticket. Okay. So y equals 2 times 1 over 4 to the x power minus 5. Actually, I'll do plus 5. Plus 5 minus 3. Okay. So copy that down, and I'm just going to, again, also copy and paste something that I had from before. Group copy, paste, bring it over here. And let me zoom in a little bit too. Sorry for the pausing and stuff. I just want to make sure I can bring it over while you still copy. Okay. So in black, that's our typical formula. That's what we're working with before. In purple is the new stuff, h and k. Now, in first and second step, we're going to use the black part of it, which is we're going to find what is the values at 2 parentheses 1 over 4 to the x power. We're going to ignore that purple part, which in this case will be the plus 5 and negative 3 for now. So we're going to do the same thing that we just did, literally on the last problem, just for these numbers. So I'm going to make my table, and I'm going to do it a little bit quickly, just because I feel like we got the concept. Negative 1, 0, and 1. 2 times 1/4 to the negative 1 power. That's going to be 2 times 4, or 8. Probably a scam call. Next one, 2 times 1/4 to the 0 power. Well, 0 power doesn't do anything. It just changes to 1. So it's just going to be 2. And 2 times 1/4 to the 1 power, which is just 2 times 1/4. If I were to make this a fraction, it'll be 2 over 4, which will be 1 over 2. I think a lot of you guys prefer decimal, so I'm going to change it to 0.5. 1 over 2 becomes 0.5. Now, that stuff that I just did, we done that. We did that twice already. We're pretty good with that. You'll have more practice with that. What is new is this H and K stuff. This H and K stuff should remind you of vertex form, where we're going to identify what our H or K is, and then we're going to add, there if it's negative, subtract it from both sides. Here is the important thing that I know somebody will forget eventually. So I want you to be the person to say to yourself, I'm not going to forget this. This is negative H. Because it's negative H, when we take the value here, which was a +5, we're going to flip the sign. So H is going to be -5. Why do I flip the sign, you might say? Mr. Tobel, why do we flip the sign? Because if it's minus -5, that would cause it to be a +5 and match the top. That means H has to be -5 in order to match the top. Do you need to understand fully the reasoning? Not really. All you need to remember is that because it's minus H, you're going to flip the number you see here. So instead of +5, it's going to be a -5. Go ahead, Mariah. K, on the other hand, is just positive K. So you could rip it off as it looks like. So here it's -3. So I just put -3. Now, what does that H and K do anyway? What that allows me to do, is bring this new table over. So I have a new table. And what's going to be different is that I'm going to add, or in this case, subtract 5 from the X. My H's are going to go with the X's, while my K's are going to go with my Y's. So since this is -3, I'm going to subtract 3. So I'm going to make a new table with these new values by adding H and K. Now they happen to be negative, so that's effectively subtracted. So over here in the first box, I have -1 minus 5. -1 minus 5 becomes -6. Over here, I have 0 minus 5. 0 minus 5 is -5. And over here, I have 1 minus 5. 1 minus 5, -4. On the right side, I'm doing -3. So it was 8 minus 3. So I take the number here and just subtract it by what my K is. So 8 minus 3 is 5. 2 minus 3, that happens to be a -1. And 0.5 minus 3. No shame pulling out the calculator, but this would be -2.5. So the third step right here, all you have to do is change the values based off H and K. So whatever your H is and whatever your K is, you're changing it to that new table, the new table right here. Okay. I'm going to pause this so you guys can copy this down as I write the final problem. Does anyone have any questions on this? Does anyone have any questions on this? Don't be afraid to ask. Sorry for this random zoom out. Just gotta have some space here. All right. To see if you understood the lesson, Your Exp ticket is right here. Y equals 6, 1/2 to the power of x plus 3 plus 2. What I want you to send me is the y values of the new table. So whatever the y values of the new table for this one, I want you to get me those. Like if it was this one, you would type 5, comma, -1, comma, -2.5 for me. It's okay to use a calculator. I recommend using a calculator to avoid errors, especially when you deal with negatives. So try this problem out. I'm going to do a problem on a piece of paper for me so I can have the answers ready to check with you. So try this problem out. Carmela, is everything okay?
Yeah, I'm sorry.
What happened?
My dog is like having issues.
Okay. I recorded this lesson, so make sure to check it out after. Alyssa, you got the answers. You're free to go. Is 3 negative? Your
Okay.
H value would be -3. Good. Yes, Ella. Alyssa, you got the answer. You're free to go. And Ella, to your question, 3 would be negative for the H, but the K is just +2. The K does not change, so that's going to be a +2. So K is +2. Only the H one you flip the value. The one is Ella and Ben, you're free to go. So Carmela, the screen up here is based off, it's basically the same as yesterday's lesson. We're just dealing with numbers lesson 1. In this one right here, Ben and Ella, you're free to go. Wonderful dog. Here, what we're doing is finding the values for the shifts. So this is the H and K.
So
So,
you just wanted to give me the other part?
so what you need to send me is the Y values.
Okay.
All right. Haley, good job. You're free to go.
Thank you. Have a good day.
Hey, you too. Carmela, straightforward and quick. You're free to go.
Thank you.
What's the K?
The K would be this number right here. So that would be a
okay.
+2. The H, you have to flip the sign. So that would be a -3.
Oh, I'm getting it right now.
Yeah.
So that's that.
I'm just writing it down because if somebody watched this recording and I just said like, yo, you got it right, they don't know if you got it right. So I'm just writing it down for the recording in the future.
Okay.
For the future person who watches.
I'm gonna guess it's 14, 8, and 5.
Perfect. 14, 8, and 5. Because you would add 2 to both of these.
Okay.
Right.
Thank you very much, Mr. Double. Have a great day.
You too, Naho. Have a wonderful day. Make sure you do your homework.